This is the virus known as the SARS-CoV-2 virus, which causes the disease COVID-19. By March of 2020, the coronavirus has swept the world into a pandemic, spreading rapidly from country to country without a hint of slowing down. These pictures reveal insights as to how the virus spread, but more importantly, how we can contain it. But how can we see it? The virus is very small. It has an average diameter of 80 to 120 nanometers. The normal microscopes, optical microscopes, simply do not have the resolving power to produce a good image for the coronavirus. Optical microscopes utilize the visible light spectrum, which has a limited wavelength of 400 to 700 nanometers. The wavelength limits the resolution, therefore it can't resolve or capture the detail of any sample or specimen that is too small. This happens because of the diffraction of light that occurs, which makes the image of tiny specimen blurry. The smaller the specimen, the greater the diffraction, and the blurrier the image is. But that also means that if the microscope uses a shorter wavelength, it will be able to resolve smaller specimens. This is where electrons come in. Quantum physics tells us that matter particles like electrons can behave both as a particle and a wave, which means electrons also have wavelength. Therefore, we can use electrons in replacement of photons. The de Broglie wavelength equation states that the wavelength of a matter is inversely proportional to the mass and velocity of the particle. Using a fast-moving electron, we can produce a wave with a wavelength about 1,000 times shorter than that of a photon. The shorter wavelength decreases the occurring diffraction, which results in a higher resolution that is needed to inspect small specimens like the SARS-CoV-2 virus. There are two types of general electron microscopes: scanning electron microscope, SEM, and transmission electron microscope, TEM. SEM scans across the specimen, sending beams of electron at the sample, and producing an image by collecting the reflected electrons. TEM transmits electron through a specimen and creates an image of the cross-sections, providing details inside the sample. From the pictures, we can see the shape of the coronavirus. The virus has a membrane-bound core, but more importantly, spike glycoproteins that covers its surface. It's with these proteins that the virus is able to attach to human cells and infiltrate our body. If we were able to block these spike proteins, then it will limit its ability to enter human cells and spread. Electron microscopy provides images for the coronavirus outbreak. However, it doesn't provide the actual solution to solving the pandemic. But more importantly, it provides something we can see with our eyes, a future we can hope, and the courage to keep on fighting for the answer.